Hi, my name is Chandra, Balaratnasingam, and I'm one of the retina specialists from the Lions Eye Institute in Perth, Australia. So this research that we'll be undertaking in collaboration with Monash University is looking at the cellular mechanisms that cause blood vessels to shut off in the macula in patients with diabetes. That's a manifestation called macular ischemia. And that's the most common cause of irreversible vision loss in patients with diabetes. So we're trying to understand that condition better and hopefully develop new ways of treating that condition in two ways. One is to actually prevent it from occurring in the first place, but the other is once you get this shutdown of the circulation to the macula, how we can restore it in order to improve vision. Look, I think it's really an unmet need with respect to our knowledge in the field of diabetic retinopathy. We have good treatments for diabetic macular edema, but for macular ischemia we have none. And as I said previously, that's what causes patients to go blind, and we can do really nothing about it. So, the purpose of this research is really to inform us as scientists what causes this manifestation. The second is to develop new treatments in terms of what's tangible to the patient. Really I envisage it to be knowledge that we can use to develop new treatments and to improve their visual outcomes and to reduce their rate of vision loss and blindness. So I really do see it as a translational benefit, this knowledge that we're going to gain from the study. I've been involved in vision research for almost 20 years. I started when I was a medical student. I did my PhD in the field of glaucoma actually, and that was a lot of basic science research looking at how the ganglion cell axons in the retina die when the pressure in the eye goes up. But as part of that research, we actually looked at an ischemic insult to the retina. Using animal models, we shut down the blood supply to the retina and looked at how the axons died, and I was really intrigued by that. After I finished my PhD, I went on to train in ophthalmology. I enjoyed the retina diseases the most, so I became a retina specialist. And then after returning to Perth, I just found that patients with diabetes, there's a lot we can do for them, and there's a lot we can't do for them. There's a lot of people from diabetes, particularly working age people, that suffer devastating vision loss, which has a huge impact on their life. And I just felt that I had the perfect background and research to investigate this topic further. And I was well placed and had all the support to study, the cellular biology of diabetic retinopathy. Certainly, it's a very fascinating disease. It's not just a disease of neurons, it's a disease of the circulation, a disease of astrocytes and glial cells. There's a lot of clinical application of basic science research. And every day I do the research and work with a team of researchers. We're learning things, and it's just really exciting. So for me, it's really the path forward in terms of my career, continuing this research on diabetic diseases of the eye. Yes, I have many patients like that, and a lot of those patients are working age people, young people in their 30s and 40s. They've got bad retinopathy, which has resulted in the macular circulation just completely shutting down, and now they've got, what's determined to be legal blindness. So, I think you have to put those things in context. It's a little bit different to age-related macular degeneration. You have patients in their 70s who have vision loss, and that's very crippling. But when you have an adult that's in their 30s, they can't work, they can't support their family, they've got 40 years ahead of them potentially in their life where they're going to be limited by this vision. So it's a devastating complication to suffer from diabetes as far as the eye is concerned. And it's not just the physical impact on these patients, the mental burden. They can't work now, they don't have a job, how do they support their family? It's really, it's not a trivial thing to suffer. And then you have to look at the economics of it and the impact that sort of burden puts on the health system in Australia. We have to support these patients, and help with their mobility. The carers have to take time off work to drive them to their appointments. So there's a huge financial burden to the health sector there as well. So it's one of those conditions which I think we really do need to urgently address. You know, we have to find a way to, at the very least, improve visual outcomes in these patients such that they can function. Yeah, I think, you know, if you speak to patients with any eye disease, a lot of them will tell you that, you know, they'd rather die than go blind. And that's the same for diabetes. So they, you know, a diabetic patient will manage quite well with an amputation of their toe, or they may have renal failure and they will manage with dialysis and those sorts of things. But once you take the sight away from them, then the impact is real to them. You know, they really struggle to do, you know, things around the house, you know, just function and, you know, just the activities of daily living. So I think, you know, our mission should always be to preserve excellent vision and minimise vision loss. I think the burden of that is often underestimated, but if you speak to these patients, which I do, I've had many of them as a clinician, you know, they do suffer quite a bit as soon as they lose that central vision. It's very difficult. I mean, that's basically the short answer to the question. There's two things. The funding amount is going down, so it's more competitive, and the priority really is for cancer research, dementia research, and that's understandable. So in terms of the pecking order, ophthalmology and retinal diseases is right down the bottom. So it's extremely hard. I mean, I put in grants, you know, several grants every year, and you know, the success rate for something like an NHMRC grant, which is probably the most prestigious and the most useful for a clinician scientist, you know, it's much less than 5% success rate. So it's a lot of work to write these grants. It's a lot of time away from work and family. And it's very disheartening when you don't get the funds to do this important research. Like this study, I think, will be so important for our management of patients with diabetes. I think it really has the potential to be a game changer. I hate using those sorts of words, but if you get, you know, the results we're hoping to get, then we can really apply it to help patients in a meaningful way. I can't really thank the donors enough for the funding that they've provided for this important study. Given how competitive grants are for clinician scientists or researchers in vision science, this is really, I can't thank them enough, basically, for the opportunity that's been provided with the funding. It's an exciting grant, it's an excellent grant to get, and it'll be money that will be well spent on science. And hopefully, you know, we can really make an impact in improving eye health with this sort of with this research.